So my name is Awais Piracha. I am Professor of Urban Planning at Western Sydney University in Australia. So I'm very grateful for the Kuwait Society of Engineers for inviting me to this. So Kuwait Society of Engineers invited me here. I'm a member of the scientific committee of this conference, and I welcome you to this session. This session is about sustainable urban planning, so which suits me very well. I started as a civil engineer and then studied environmental engineering and then urban planning. For the last 25 years, I have been serving as an academic, and now I am a professor at Western Sydney University. I have also had various leadership positions in the university. Previously, I have worked in several other countries, notably in Japan, in Germany, Thailand, and Saudi Arabia. So welcome to this session. We have 8 presentations, which means we have about 15 minutes for each presentation. But because we would like to have some questions and answers also, so I suggest that we give about 10 to 12 minutes to every presentation. So I'll prompt you if you go for longer than that. And following that, we will have maybe 1 or 2 questions from the audience. If nobody asks questions, I will ask questions. So be ready for that. So with this introduction, maybe we can, if you look at the schedule, my paper is listed first, but we have someone, one of the presenters has a flight, so I have decided to swap my presentation with him, so I'll go last now, and they will go first because they have to leave. So with this, it is my pleasure to introduce, and now I have to open up my phone because that's where their introduction is. So this is my pleasure to introduce Engineer Abdullah Ahmed Said Al-Balushi. He works in logistics operations. He's a logistics operations specialist at the Oman Logistics Center. His work focuses on logistic operations and infrastructure systems within the context of national development. So, Engineer Abdullah, please come.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdullah Ahmed Al-Balushi from Ministry of Transport, Sultanate of Oman. Today I will speak about one of the leading projects in our country is National Port Community System. First of all, the agenda of this presentation is introduction to the National Port Community System, then the NPCS implementation approach, finally the question and answer if you have any question. What is National Port Community System or NPCS? NPCS is one of the initiatives to facilitate trade and streamline the movement of cargo in and out of the country, and they have different objectives like improve of easy of doing business, positioning Oman as preferred gateway hub by reducing the cost for consumer and the industry. The objective of this project is to digitization and paperless transaction, cost and effort reduction, reduce possibility of fraud and leakage in the system, centralize information flow, data digitization for enhanced analysis. As you see, National Port Community System has a different community under it. For example, maritime community, landside community, dry port community, cross-border community, free zone community, airport community, finance community, and trade community. And these all under the National Port Community System and will be integrated with different stakeholders like port operation and the terminal operation, custom and immigration, billing and invoices system, payment gateway, and API and ADI messages. The main stakeholder for this project, as you see there, shipping line, airline agents, freight forwarder and custom brokers, ground handler, transporter, and rail operator, other government, all they submit their paper through the single window, which sending to the port and the airport and the free zones. The system we are using now in Oman is Bayan system. Then we will bring the port community system, national port community system, and have port community system, airport community system, and cross-border management. The use cases for each one, for example, for the port community system, maritime single window, vessel profile, road transportation, e-payment, manifest. And the airport cargo community system, we have the e-airway bill and the truck slot management. These are the main two in the ACS, airport community system. And the cross-border, also we have use cases like the slot management, clearance, and immigration management. The key benefits of NPCS: enhanced stakeholder management, improved transparency, enhanced monitoring, centralized data, and support for economic growth, reduction in congestion, and cost saving. These are the main benefits of NPCS. The implementation now, we are starting in the phase 1, and it's starting in, as you see the map here of Oman, we start in Suhar Port and Muscat International Airport as a phase 1. Then we will go across to the other ports and other airports in Oman. Thank you so much. If you have any question, I will be happy to answer you. Anyone has a question? Thank you. No one has a question? Okay. Further. Yes. 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 Yeah. Each port have their own system. So we will integrate all the system in one single window, in one place. I know it is very يعني مشروع جدا صعب because we have lots of stakeholders, but we will bring it all of them together. We are starting now around 1 year, and we just finished one port and one airport, and we have lots of airports. And
but for whom do they report? You know, actually, all of these ports.
Yeah.
Is there a main body that they report to?
Yes, main stakeholder, you mean?
Oh yeah.
As you see here, this is the main stakeholder: freight forwarder, custom broker, airline agent, shipping line, and the ground handler. All these are the main stakeholder in this system.
It's all private, not the government.
Some of them private, and some of them is government.
Since it's like, thank you first of all for your presentation and your abstract. But I'd like to ask regarding the your data center. So most of your stakeholders is mixed between the government and the private sector.
Yeah.
So, and this is one of the challenges actually we face, that the data center, where it should be located, and these data, who will control them?
This project is an investment project leading by the Ministry of Transport, and the company which get this investment opportunity is Novel Muscat International. And one of the main thing that we have it in this project, that the hosting data, this data in Oman by Oman Data Park. So all the data will be in Oman, inside Oman.
But who is controlling this data? Who's controlling
The
this
ministry.
data? The ministry itself.
Yeah.
Thank you.
Thank you. Thank you so much.
Okay, so for the next, I had it on my computer, but it's running out of battery. So that's why I have it here. The next speaker is Engineer Abdul Hadi Al-Khatani. He works in the communications department within the project management office at the Management at Qatar University and a member of Qatar Society of Engineers. So we can find you here. The way to is we can close this. We can close this, and you are here.
Yes.
And we can. Yeah.
Yes. Thank you.
So 10 to 12 minutes.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, everyone. My name is Abdulhadi Al-Qahtani, and today it's my honor to present my research on quantifying the sustainability performance of Doha Metro using a composite index approach. This study actually covers the period from 2021 to 2024, including a critical time frame which is the FIFA World Cup 2022, and subsequent operational maturity of the system. So the research was conducted as a part of my academic. Before diving into Doha Metro, let us set a global context. So the urban mobility is not just about the transportation issue. It's a sustainable mandatory for the transportation system. That's why, as according to the United Nations, 68% of the population around the world will move to the cities by 2050. At the same time, 24% of the global CO2 emissions is coming from the transport sectors. That's why the United States set some goals for the sustainable development, which is the SDG 11, the Sustainable Cities and Communities. And they aiming to reduce the road congestion, also lowering the carbon, improving the air quality, and fostering the social mobility. Now let us move to Qatar with the Doha Metro, one of the mega projects that Qatar built it. And Doha Metro actually was designed to align with Qatar National Vision 2013 that have 4 different development pillars: environment, economic, social, and human. Regarding the environmentally, actually it serves to low carbon public transport. Economically, it provides infrastructure that's supporting the economic activity. But socially, it's offer the accessibility of the mobility, fostering social inclusion. In human perspectives, it's create opportunity for the Qatar national and residents, and give them the skills training opportunities. And Doha Metro actually is an impressive systems. It's launched on 2019, and it spans over 76 kilometers with the 37 stations across 3 different lines. And their system actually is called Go of automation for a system. And that's mean a design that there is no driver, it's fully automated. And this makes the Doha Metro one of the advanced metro in the region. Despite the success operational of the Doha Metro, especially during the World Cup 2022, there is some research gap in this field. First of all, most of the research, they assume that their metro is environmentally sustainable. The second thing, a few studies who's studying the metro or the transportation section, a few study of them integrate the life cycle assessment with the composite sustainable indices. And the third point, actually this in the most of the research field, the regional data is void, and the data is very limited, and it's very hard to extract the data for your research. The fourth point, actually, or the fourth gap, which is the narrow scope. Most of the research in this field is focusing only in the environment without getting without study the impact of the social and the economy for their investigation. That's why the contribution of this study is to do the assessment for Doha Metro. Also, and it's not focusing on a specific period. It's over 4 years study capturing a trend over time, using 22 indicators across 3 pillars, which is the environmental, social, and the governance. After that, once we build one index, we should do a sensitivity analysis to make sure that our result is robust. So this study align or follow some research objectives, and these objectives contributes with research question. The first one is the the first objective is to construct a composite sustainable index to provide a holistic transport measure of the performance for the 4 years. The corresponding research question is how can a mathematical CSI framework be constructed to holistically measure Doha Metro performance. The second objective is assess the performance across environment, social, and the governance pillars by using sub-index trends. So the corresponding research question is, what are the specific indicators, trends, and the drivers across the environmental, social, and the governance pillar? The third objective of this study is systemically link indicators to the UNCGs and the Qatar National 2030 to quantify this strategic contribution and help the policymakers to decide and making them to decide and enhance the system. And the corresponding research question is, to what extent does the Doha Metro contribute to achieving these goals? The last objective is formulate evidence-based recommendation for the policymakers to enhance future system. And the corresponding research question was, what evidence-based strategies can be adopted to address this gap? So that's why I built one methodological frame, which is a systematic 4 stages approach to construct one composite sustainable index, ensuring the robustness and scientific validity. As you can see here, the first step is to collect data and then select the indicators and then do some mathematical approach, which is the normalization and the weighting and the aggregation. After that, we need to validate by using 8 scenarios synthesis analysis. Starting by the first step, during actually collecting the data, I found some difficulties, and then I found that there is some annual reports have been published from the Qatar Rail from their official website. I collect their annual reports across 4 years, and I found that 96% of their data is complete. Some data is actually having missing, and I use some regression models and mathematical motion models to fill these missing values. And the last one actually was corrected typos. The second steps is to select the indicators carefully, and I end up with 22 key performance indicators across 3 sustainability pillars, and 15 of these indicators has a positive indicators. What does mean positive indicators? As it's become higher, it's become better. And the 7 negative indicators, what does it mean? As the numbers become lower, it's going to be better. And we will see in the next slide what's the importance of this one. So since we have different indicators, and these indicators have different pillars, we need to normalize all my data from 0 to 1, so I can construct one index. I don't want to go deeply on this mathematical formula, but as become a 1, it's mean a better performance, and the score is 0, it's a worse performance. The fourth step is do or generate a weight and aggregation for the sub indices, which is the environmental, social, and the governance. But to set a baseline for my weighting system, the main concept is to have equal weighting, keep these 3 pillars equally, so no pillar dominate on the index. After that, during doing the sensitivity, I gave some different weighting for every pillar. So once we did all the methodological framework, and I end up with one CSI, we can see here there is a strong positive trajectory despite a minor in 2023. I can't highlight it there. Yes. Despite this dip into 2023, from 2022 going to the 2024, there is a strong positive trajectory. That means that 51% improvement in the sustainability in the Doha Metro system. And you can see here there is a big jump from 2021 to 2022, and this is during the effect of the World Cup 2022. And you can see here, we end up with the 2024 with a good range, demonstrate the system progress and operational environment for this system. So this in general for all these 3 pillars. Let us dive into sub indices in every sub indices. So just I would like to highlight in a quick that the governance pillar have the lead of this growth from 0.1 to 0.7, and this dramatic improve driven by near perfect about the surface performance and the enhanced training. The social also they have a steady growth, growth, and the environment they offset the lower trending by do some recycling improvement. But you can see here in the gold chart there is a big jump for the social pillar due to the increased number of the trips in the 2022. But at the same time, the environment pillars become less, because most of the people actually they waste or they consume more for the water and energy. After that, the sensitivity, we need to do the sensitivity analysis and robustness for our index. I did 8 scenarios, but let me highlight one thing is regarding the scenario 4 and 5. Sorry, for the scenario 4 and 5 and 6. It's mentioned that it's extreme environment. Sorry. Yes, I will move there to the screen. It's much. I give a high score or weighting for the environment pillar. And enhancement in every year. So the Doha Metro actually team, they focusing to enhance also the environment. Here I give for the governance from very short one to a very big scale. So in every pillar you can see here there is enhancement in every section or in every. Okay, and this driven actually by in the environment, they focus to aiming to lowering the consumption. But at 2024, instead of lowering the consumption, they focusing on recycling the energy and the water and the waste. And this very good thing from the Qatar Rail management. The second thing for the social, the splitting contribution between the road accident and the passenger trip are almost the same. So as the passenger trips increase, the vehicles removed from the road is also increased, and this enhance our you know, the our accident avoidance in the road. For the governance part, they focus to enhance the satisfaction of the customer, the satisfaction of the service, and also training their people. That's why the index is lead by this pillar. At the end, I aligned all what happened of these numbers with their Qatar National Vision 2030 and also the SDGs. You can see the Doha Metro contributes to human developer through staff training, and also for the social development through enhanced mobility and accessibility, and economic development through the infrastructure investment and job creation. Also for the environment development through the carbon reduction and sustainable transport. And here is the key findings of this research. If you have any question, Professor Owais is always pushing me through the to end. It's fine. Yeah. Thank you, guys. Thank you.
Hello, everyone. My name is Arijal Banwan, and today I'm going to be giving a presentation on our project titled Modular Construction as an Emerging Approach for Residential Expansion in Kuwait. So like many rapidly developing countries, Kuwait faces growing pressure on its housing sector due to rapid population growth and rising housing costs. So many houses in Kuwait respond to this by vertically expanding their homes, by building an extra floor on top of their house to accommodate their growing families. So this creates demand for faster, less disruptive, and more efficient methods of residential expansion. So modular construction is a modern method of construction that offers shorter build times, reduced site disruption, and lower construction waste. Despite growing international interest, this area is still under development in Kuwait, and it's not fully established. So our research examines the modular construction industry in Kuwait to see its potential for sustainable vertical housing in Kuwait. So let's first look at some key definitions. So off-site construction is a construction approach where building elements are manufactured away from the construction site and then delivered to the construction site for assembly. Prefabrication is a form of off-site construction where individual building components are manufactured in a factory and then brought onto site to be assembled, such as wall panels, roof trusses, etc. Modular construction is an off-site construction subset where entire pre-designed building components are fabricated off-site and then delivered to the site. So modular construction methods can be classified based on their degree of prefabrication. So from lowest degree of prefabrication, we have component, panel, and volume. And then it goes all the way to the highest degree of prefabrication, which includes hybrid and complete building systems. So we'll look into these in a bit more detail in the next slide. So prefabricated components is the lowest degree of prefabrication, and this includes individual building elements such as columns, windows, or smaller sections of walls and floors. So these are prefabricated in a factory and then delivered on site where they can be installed. Next is panelized construction. This includes linear, flat, two-dimensional panels, mainly used for structural frames and walls. Third, we have volumetric construction. This includes fully completed three-dimensional modules, which are transported to the site for installation. And then we have hybrid construction, which includes various elements, mainly the top three prefabrication techniques. So it can include linear components, panels, and modules to create a mixed construction system. And then finally, we have complete building system. This is the highest degree of prefabrication. So essentially, the building or structure is prefabricated to a high degree of completion, and it's delivered to the site ready for installation and immediate use. So modular construction can be used permanently or temporarily. So for permanent usage, it's often used in residential or commercial spaces. And then temporary modular construction can be relocated. So it's often used for disaster relief housing, medical facilities, and sometimes on construction sites to host the laborers. So modules can be prefabricated from multiple materials, mainly wood, cold-formed steel, hot-formed steel, concrete, and a blend of materials. So in Kuwait, we mainly use cold-formed steel and hot-rolled steel. Cold-formed steel is lightweight, so it's often used for residential buildings and fast-track projects. Hot-rolled steel is heavier, and they often use it for large spans and heavy structural demands. And the selection of the material is often affected by the project's specific needs, site-related factors, and budget considerations. So here we're just going to compare modular off-site construction and traditional on-site construction. So as you can see in the construction schedule, the design, permitting, and foundation stages often take the same amount of time in both construction methods. However, when it comes to on-site construction, modular construction, almost more than half the time is saved during the construction process in comparison to traditional construction, because most of the construction is actually done in a factory site, which can happen at the same time as they're doing the foundation. So this time-saving aspect not only expedites project delivery, but it also translates into financial advantages. So the benefits of modular construction worldwide includes increased speed, increased quality control, installation efficiency, increased labor efficiency, reduced environmental impact, and minimal disruptions, because you can stay in the building while the construction is happening, because they're just installing the materials on site. They won't actually be constructing. So this is one of the biggest benefits. And also it's up to 50% faster than traditional construction, as we saw in the previous timeline schedule. So some of the challenges of modular construction include transportation, logistics. So often specialized equipment is required for oversized modules, and this can cause some added costs, some delays, and added complexity. Also, there are on-site challenges of using this construction method, because you can't really resize or reshape the module on-site. So you need to make sure that it's correct before bringing it into the site. Also, modular construction is not suitable for all building types. So high-rise buildings or seismic zone buildings, this type of construction method is not recommended. Off-site challenges include, in order to do this type of construction, the contractors need to establish a fabrication plant. So this can cause increased capital expenses at the beginning. Also, public perception. So there's generally non-acceptance by the general and sometimes professional public on this type of construction method. So in our study, it was kind of a qualitative study. So we did survey distribution, where we distributed questionnaires to contracting companies involved in off-site modular construction in Kuwait. The respondent profile included engineers and senior professionals from general and subcontracting firms with 10 to 20 plus years experience in modular construction. We then did some semi-structured interviews with managers from each of these contracting companies to capture insights beyond the surveys. So quantitative results. We first looked at client awareness of modular construction in Kuwait, and our findings revealed a very low level of client awareness. So only 83% of the contractors stated a lack of awareness among their customer base. We then looked at the types of modular construction used in Kuwait. So our results showed that 67% adopted permanent modular construction. So this shows the client preference for permanent versus temporary usage of this construction method in Kuwait. We then looked at the types of clients that often request modular construction in Kuwait. So residential clients ranked first, showing the highest demand, followed by commercial, medical, and institutional clients. We then looked at the key advantages driving client adoption of this construction method. So shorter construction time ranked as the primary driver, reduced waste and on-site noise followed closely, and shorter material supply time and cost reduction shared third place. So we then looked at the types of modular construction offered in Kuwait. So 4 types showed up. Panelized construction was the most common type that they used, which is the second figure. And then prefabricated components and volumetric construction were less common, but still used in Kuwait. So this just showed what are the different modular options available in the Kuwait construction industry. So we then did some qualitative studies and did some case studies. So this is one case study analysis of modular construction used in a residential house in Kuwait. So this was a normal residential client. The project purpose was to extend the house. So this is actually very, very common in Kuwait due to housing prices being really expensive and people in Kuwait needing to expand their homes. They often always add an extra floor in their house to accommodate their growing families. If their son got married and needs to move somewhere, this is very common in Kuwait. So modular construction is a very sustainable option to use for this purpose. The project took 4 months to complete, which was much faster than if they had done traditional construction. It cost 30,000 KD and was over 250 square meters. So we then listed some of the materials that were used. As you can see in figure A, this was the residential house before construction. And then in the second and third figure, it shows the house roof being prepared and the floor extension under consideration. Okay, so our study then finalized with what the main drivers are to adopt modular construction. So project delivery, so faster construction time was a major driver. Site conditions, this was another major driver. So reduced noise and dust during the construction activities, having a cleaner and more organized construction site, and the ability for residents to remain in their home during construction was one of the main sustainable benefits that led clients to choose this type of construction method. Cost considerations as well. So modular construction can range from 30% similar to conventional construction based on the system employed. So the cost depends on the type of structural system you use, whether it's hot rolled or cold formed steel, and the selection of wall and cladding materials. But it's often 30% cheaper than using traditional construction. So then we looked at some of the specific challenges in the Kuwaiti industry when using this type of construction methods. So many existing residential buildings in Kuwait cannot structurally support additional vertical loads because the houses weren't built to be able to take on more load in the future. So this was one of the main challenges. Also, differences between the original design drawings and the as-built drawings caused some issues for contractors because they weren't able to determine the extra load that needed to be taken because the as-built drawings were different from the design drawings. Also, municipality regulations. So the built-up area to land ratio. So in Kuwait, we have certain ministerial rules. So we're not allowed to build more than 100 square meters on the second floor. And the maximum building height is 15 meters. So due to these regulatory challenges, it can restrict or prevent the approval of residential expansions in Kuwait. Other challenges included logistical challenges. So our roads are very narrow in certain areas. So this can limit crane access, bringing in the materials. So this was another challenge faced by contractors. Other environmental challenges include weather, sandstorm, extreme heat, and also workforce capacity. So we don't have a lot of labor that are specialized in advanced modular systems. So this kind of limits the use of this type of construction in Kuwait. So after looking through all of the surveys, meeting with contractors, and doing some case study analysis, we came up with some recommendations to promote sustainable modular construction in Kuwait. One of the main industry recommendations was to offer turnkey modular solutions. So mostly the contractors will offer and supply the structural components, and then another contractor will come and install it. So it's recommended to offer turnkey solutions where one contractor can do everything from integrating the structure, MEP services, all the way to finishing the project. Also awareness. So it was recommended by the contractors to improve client awareness about modular construction as a construction method. Workforce capacity was another recommendation to help address the shortage of skilled and specialized labor and to establish minimum wage standards for these type of labor. Addressing end user complaints was the main recommendation because two complaints, mainly roof leakage and noise complaints, were the most common complaints by end users. So roof leakage is likely to happen when using modular construction if you're using finer roofing materials to ensure that it's cheaper. So the problem is often resolved by the insurance offered by the contractor or by using more expensive roofing materials such as SPF, which is spray polyurethane foam. Another complaint is noise complaints. So the cladding material needs to be carefully selected to determine the level of soundproofing for the structure. So basically, our study just looked at modular construction in Kuwait. It hasn't been looked at before from a sustainable viewpoint. So we looked at it in Kuwait, saw what industries it works in, and what is the most adopted approach. We found that client awareness is low, however, demand is high. So clients ask for a way to expand their buildings quickly and cheap, and they end up using modular construction, but they're unaware that this building method actually exists before asking for these requirements. So residential clients were driven by shorter construction time, reduced waste and on-site noise, and the ability to remain in their homes during construction. Wider adoption is limited by structural constraints, regulatory approvals, logistical challenges, and workforce gaps. So we plan to develop the study into the future, and we plan to look at end-user experiences. We plan to also look into materials and long-term performance of modular construction, and also look at structural readiness of residential buildings. So some old houses might not be able to take on the weight, so we plan to do some extra analysis on these type of houses. Thank you so much. I can't hear him. Sorry.
What kind of challenges do you face, in constructing this type of construction
I'm sorry, I can't hear you.
I'm saying, what type of challenges do you face when you construct these buildings with the municipality itself? What kind of things that they put in front of you that challenge you actually?
Okay, I'll tell you. So basically we have a ministerial resolution number 451 of 2016. So this has the requirements and specifications for the typical residential buildings in Kuwait. So these are the rules, I will list them now, okay? So the proportions of the buildings will be distributed over 3 floors. And this includes permission to build on the roof of the second floor with an area not exceeding 100 square meters. Okay, this was later developed in 2025 to say that building heights were maximum 15 meters, but now building heights can be maximum 20 meters. So this is really good because now we can extend the floor. But this rule just came up in November 2025. Before we only had 15 meters to extend the house. And then the built up areas of 100 square meters. So this is the limitations when it comes to municipality.
Yeah, thank you very much, Engineer Arid. And your challenge, also I back to my colleague, because I'm 30 years in municipality.
Okay.
Regulation, I did the regulation in 2006.
The old one, 2016.
Yeah, you are right. There is municipality regulations is very, very, very strong and tough for this idea. I think you need to add something. Yeah, the culture of your community, you have to understand what the concept of that. Because they are looking for the concrete, not looking for the lightweight of the building, because this is called structure frame, you know that. Just this point, if you add it, is better, because you need to give him learn or something for the people, awareness. The humanity, and understanding this idea. They are looking for something strong.
Strong, and yes.
Yeah, thank you very much.
You're welcome. Yeah, so basically that is one of the things. So client awareness is not known, but they still demand it. I mean, we have clients that come and they'll ask for, I want you to do something and I want you to do it really fast and I want it to be cheap quality. Contractors will offer this method of construction. So if okay, yalla, we'll do it. But they don't actually realize, okay, it's a so client awareness, we need to help explain it to them. But it's very common in chalets or farms. It's very common, but they don't realize that this is what they're actually using. We're still at the beginning phases, but inshallah, we'll get there. You're welcome.
Good afternoon, everyone. I would like to thank Kuwait Society of Engineers for the nice hospitality. And today we will present about investment, sustainability challenges, and innovative solutions in smart infrastructure projects, especially in engineering and environmental sustainability. And this is the title of our conference in Kuwait. We'll go to the outline. We'll start with the introduction, problem statement, research gap, aim and methodology, key results, implications, and finally conclusions and acknowledgements. The rapid urbanization and accelerating climate pressure has intensified demand of smart infrastructure capable of delivering sustainable and efficient urban systems. While smart infrastructure projects enhance environmental performance, their implementation is hindered by fragmented approaches to the key project dimensions, which is finance engineering and sustainability. This photo shows one of our most popular city in Qatar, which is Al Waseel city, one of the smart city in Doha. The problem statement, we focused on the key project dimensions. There are 3 dimensions: finance, engineering, and sustainability. And these 3 dimensions are addressed separately. And this cause also limits the project success, and this alignment between engineering and sustainability increases the risk and reduces the performance of project. The research gap, we find that there are very limited integrated studies, and there is also lack of linkage between the 3 key dimensions: finance, engineering, and sustainability. And we need for a holistic smart infrastructure frameworks. The aim of the study assesses integrated finance and engineering for sustainability in smart infrastructure projects, and also to identify investment challenges, engineering innovations, and sustainability outcomes. And finally, to develop a conceptual framework between engineering, finance, and sustainability. Methodology used was a qualitative comparative analysis between many case studies and a systematic literature review. The competitive analysis enables identification of best practices and sessions and lessons learned across infrastructure sectors. Case studies analysis of smart infrastructure projects across different domains, and systematic literature review of peer-reviewed journals and policy reports. Infrastructure domains, we focused on 4 domains: transportation, energy, water and wastewater, and smart buildings. And smart transportation systems usually use platforms, sensors, and artificial intelligence, traffic management to reduce emissions and operational costs. The smart renewable energy system enable real-time monitoring and improved energy efficiency. The digital water management system improve leak detection and energy efficiency in the treatment processes. And smart building integrate automation, energy management systems, intelligent materials to reduce the cost and environmental impact. The key results determined in this research that we find there are investment challenges in smart infrastructure, and we chose the 3 main challenges. The first one is the high capital cost due to advanced digital technologies, and the effect was that limits the private investment. Second challenge is uncertain return of investment due to long backup periods, and this has caused the investor hesitation. And the third challenge is the risk allocation, weak risk sharing mechanisms, which cause the delays of a project. Engineering innovations, using smart materials with enhanced durability and to lower the maintenance requirements. Another engineering innovation is using the digital twins for real-time simulation and optimization. And today we used the concept of artificial intelligence, which is AI-based monitoring system, and finally using maintenance technologies to predict any error happened in the system. Sustainability outcomes to reduce the life cycle cost and improve efficiency of energy, and also lower the carbon emissions and enhance infrastructure resilience. Some innovative finance models. We choose the three main finance models, which is sustainability-linked bonds. This system ties the financial returns to sustainability performance. And using a blended finance mechanism to combine the public and the private sectors together. And the coordination between public-private partnerships to allocate risk and rewards more effectively. Integrated frameworks. The conceptual frameworks between engineering, finance, and sustainability. This performance-based alignment to ensure that the three key project dimensions objectives reinforce rather than undermine one another. As we discussed, the finance to have the investment, the risk sharing, the return on investment, and this will lead, will give us the engineering innovations, the digital twins, AI system, and smart materials. And the linkage between finance and engineering will lead to sustainability outcomes, the energy efficiency, emission reduction, and the resilience. Implications, policy. The policy markers should promote framework to encourage innovative finance models and sustainable performance. Engineers should adopt smart design approaches to integrate financial and sustainability consideration from the beginning of any project. Investors should reduce risk and enhance return by supporting projects to align advanced engineering solutions with sustainable linked financial mechanisms. Conclusion, three main conclusions: that integrated finance and engineering are very critical, and alignment between them enables sustainable smart infrastructures. The framework supports the policy, engineering, and investment decisions. Acknowledgements, would like to thank the academic and research institution contributing expertise and resources, and also thank the industry partners for providing the case studies and the conference organization and peer review. Also the funding bodies and sustainable initiatives. Thank you for your listening. Any questions?
Bismillah ar-Rahman ar-Rahim. Good afternoon, inshallah. Today, inshallah, I would like to present a research. It was in my PhD course with Dr. Faisal Ajabani about mass housing in GCC. A background. We're facing a problem and we'd like to accelerate the growth when population are, we have a problem, population and growth, and the demand of need for housing also is accelerating. So now what we have is the cast in situ, reinforced concrete and skeleton system, or what we call the frame system, and takes long time. Even for cost and even for other time. So the problem would like to rapid the cycle of construction. There is no framework to support even the client, the owner, to choose any system, of course. The aim of the project to identify a construction system to improve delivery speed and envelop, of course, the performance. And as we know, the thermal problem, the hot and arid climate is a problem in GCC. As objective, we compare five systems. We'd like to show, inshallah, in the next slides. And I mention also here one case study in Kuwait, in Taima, in Jahra. The mass housing, the system in Kuwait is loan and land. The owner take like 70,000 KD from the KCB, the bank, and it is a cycle between the bank owner and the insurance, the housing in Kuwait, the housing parties. But this system is also a very slow system and not clear for the owner when he built his house. This slide just to show the anatomy of housing unit, and if there is any idea to develop the unit from to integrate the PV photovoltaic, or to consider the HVAC system through the district cooling, and also this will, of course, will reflect on the cost and time and the climate, and adapt with the climate, the arid climates. Level of construction from 2D to 3D started from 0 level, and it goes into modular, and which we can apply in the level 3. I mean, what I mean in this slide, the more if we use an industrialized and modular system, of course, it might help to rapid the speed. As a methodology, there is no numbers here, but it is a qualitative comparative review for the journals about the performance of the construction system that we take in this study. And they are 5. As you can see here, the precast concrete system, and insulating concrete form, ICF, autoclave aerated concrete, AAC, and shotcrete, and also cold form light steel. As a note here, in Kuwait, we are using the white block, which is similar, close to AAC. And in Saudi Arabia, we use they use in the Siporex in 1977. In Kuwait, 1985. This is integrated with the skeleton system or the frame system. As a comparative findings here, as we go to industrialized or modular, or of course it will help, but still we have to define, or we should open our eyes into different also material of construction. As a precast concrete system, it is, of course, here we have insulated with a sandwich panel. The material here, most of the materials from polyethylene, XPS or EPS, that can be integrated in the middle of the concrete. And we can see here a tilt up and lift up for, it is a method of construction to rapid and we have also solid and thin wall, twin wall, sorry, as you can see in the bottom. As a ICF here, it is like a Lego to construct, where we have a 2 thermal side from inside and outside. then it is filled with the concrete in the middle, and there is like a steel or in the middle to fix. So it is one part also of the system to study and to consider the energy reduction by this system. Also, there is many configuration or 3 configuration here in the system. As you can see, a solid in the top image, you can see the solid type, and then you can see a hybrid type where the mesh of steel is integrated here, or it seems like a waffle that integrated with the concrete. And on the right side, on the top, we have a column beam that integrated also with the system. The twin walls here, it can take different types. You can see in the low image, the first one on the left, it can use it for the wall, and the middle for the roof, or the, so it is different type of configuration. The autoclave aerated concrete here, AAC, this image you can see here, it is for Seporex system that used in Saudi Arabia from 1977. It is a good system for the climate and so on, but it also suffer from, you cannot modify the design, it is somehow rigid. The aerated white block here, this is a house in Kuwait, and you can see the 70% maybe, I'm not sure about the percentage, but the most of Kuwaiti houses is built like this type, where a skeleton system, what we call the frame concrete system, built firstly, then it will be, the white block will be added later on. The white masonry block, which is considered as the AAC. The AAC, white aerated, it is not concrete, it is a block, by the way. So it is one type here is going in Kuwait. The shotcrete is another system here that use a machine to spread out the concrete above the wall. But this system, of course, it was old system somehow. It is a also fast to do, but it is not clean somehow, and I don't prefer my point of view. Another system called formlite steel. There are some houses here in Kuwait, in a new city like in Matla' city, that they build their house with the steel. Most of owner see that it is expensive at the beginning, but for the long run they can reuse it, so it is sustainable. As a case study here in Kuwait, we take Taima here. It was very fast and successful project, by the way. However, the electromechanical system, I can evaluate it as a medium level, but the precast concrete was successful to apply here in this project. Finally, I reached that the AAC may represent the most practical here, and we can go with it, but as for a long strategy, the precast might be better. So it is the trade-off between the AAC and the precast. And thank you so much.
Just I would like regarding your comparison based on which indicators that you saw that this construction system is much better than the others.
Yeah, I depend on comparative analysis. I didn't take a quantitative analysis, but what they mentioned by analyzing journal and article, I came up with this. So it is qualitatively. So we analyze with the peered journal the performance, what they say and what they reach, and they came up with this. There is no equation I make here. But by statistics and looking forward about the journal and researches. So qualitative methodology.
But in your opinion, do you think, this type of structure will succeed, in the future? Because part of our culture is that we make so much openings, in these places. We change windows, we change doors. That means that we will weaken the structure itself. So I don't think, in the long term, especially for our families here, maybe this one can be applied in Europe or somewhere else. But here, I think, this is my opinion. I might be mistaken, but I think it will not be, to not make that success, That's what I think. Yeah.
My reply on that, or answer, as what you mentioned is right. The system now, you can shape it, so the skeleton system, concrete, then you fill it with the masonry. It is good for architecture to design and to modify, but it takes a long time. Compare by the precast. You by the factor, you can produce very big amount of precast panel, and so in this paper we are discussing how faster we can build, and to just let's say the demand of that many demands we have here for housing demands, to cover them. That's it.
I have a question also, sure. And anyone can answer. In Australia, most of our houses are made with timber frame. Are there any timber frame houses here or not?
I didn't get the service.
Are there any houses in Kuwait or Saudi Arabia built with timber frame?
In Kuwait, I didn't see that, precast or something. Just I'm looking, some people here, maybe less than 1% or 2% building with the steel, light steel. Yeah. And they still remain still on the old system, the skeleton and the white block, and most of.
Okay.
Yeah. So
anyone else? Is there any timber frame structures? Okay. So because almost all construction for individual houses is done with timber frame, with cladding by brickwork or by weatherboard or some other material, and inside there are gypsum board. So that's the no, not free. Okay. Allow the timber frame. Okay. Timber frame because of the fire hazard. Fire hazard is the construction. Okay, thank you. Thank you very much.
Thank you so much. Shukran. Thank you.
Bismillah. Assalamu alaikum wa rahmatullah. Hi everybody. I'm glad to sharing my idea and my concept. I use the Dynamic City from 2013 when I start Dynamic City, and I start with GCC conference, start my research. After that, I become a thought leader of the urban planning in the Asia in 2019 in Guangzhou University in China. We start today about dynamic architecture design as an approach enhancing the sustainability of the smart infrastructures and infrastructure for the projects. Of course, abstract already, I did that. Dynamic architectural design and approach, there is outline for that. My slide is more than 32, so I'm trying to press it. Doctor told me I have to be quick because of the time, I'm sorry for that. But we have to know about the dynamic cities. I'm looking to be in life vibrant city. This is the dynamic for my vision. So first of all, in this step will be an introduction, and then will be smart infrastructure projects, then sustainability dimension in smart infrastructure, dynamic architectural design in smart housing, because I'm using this part, the housing for this project. I can't to be expand in whole dynamic city because it's large meaning for that. So after that, I did the research methodology and comparative analysis of smart housing infrastructure projects. Quantitative about results and performance analysis. Then will be discussion about it and implications for smart infrastructure planning and design. Conclusion and recommendations later on in the 10th stage will be. About introduction, we have to know about or define the dynamic city before that start, to know the meaning about that or the conceptual about it. So in recent decades, the rapid transformations of urban environment and increasing pressures associated with the population growth, climate change and resource security have significantly and rapid with the way infrastructure projects and conceived and developed. In this context, smart infrastructure projects have emerged and fundamental pillar for the achieving a sustainability development, as they play the vital role in enhancing services efficiency, optimizing resource or consumption, and improving the overall quality of the urban life. Smart infrastructure projects are no longer limited. That's the conceptual about dynamic to understand the meaning for dynamic. So to the integration of the digital technology and intelligent management systems. Rather, they present a comprehensive approach the companies, technology innovation with the special environment and social considerations. One of the criteria challenge facing smart infrastructure development lies in the limited integration of the dynamic architectural design within planning and implementations framework. Dynamic architecture design offer a promising response to this challenge by introducing adaptability responsiveness, the flexible into the architectural dimension of the infrastructure projects. Thought using the adaptive facades, reconfigurable and space and interactive environmental systems, dynamic design enable building and infrastructure facilities to respond effectively to the environment and operational change. As a result, architecture dynamism become a key contributor to enhancing environmental performance, reducing energy consumption, and improving user comfort. Despite its potential, the roles dynamics architectural design in supporting the sustainability of the smart infrastructures projects remaining explored in architecture and planning research. Most existing studies focus primarily on technological systems, data-driven management, or energy-efficient equipment, while in architecture design itself is often addressed in the secondary of fragment manner. This research seeks to address this gap by positioning dynamic architecture design as a strategic approach for enhancing the sustainability of smart infrastructure projects. According to the main objective of this research is to examine the role of dynamic architectural design in improving the environment economy. Improving the environment economy and social sustainability of smart infrastructure design in improving the study is grounded in the hypothesis that integrating dynamic design principles into smart infrastructure planning contributed to increase adaptability, improving operational efficiency, and enhancing long-term sustainability, particularly in the context of the rapidly evolving urban environment. So, start with the smart infrastructure project. That's meaning we have to know about smart infrastructure projects. Smart infrastructure projects present a new generation of infrastructure system that integrated advanced technology with the physical assists to enhance efficiency, resilience, and sustainability. These projects encompass a wide range of urban systems, including transportation networks, energy and system, water and water waste, and waste management facilities and public services of building. The defining characters of the smart infrastructure lies in its ability to collect, process, and respond to real-time data in order to optimize performance and supporting informed decision-making. So, at conceptual level, smart infrastructure is based in integration of the interconnected dimensions, technology, intelligence, or operation efficiency, and spatial and architecture design. The technology in intelligence refers to use of sensors, data platforms, automations, and artificial intelligence to monitor and control infrastructure system. Operation efficiency focus to improve system performance, reducing costs, and enhancing services reliability. Meanwhile, the architectural dimension shapes how infrastructure interacts with users, climate, and the surrounding urban context. While significant progress has been made in technology and operation aspects of smart infrastructure, the architectural dimension often remaining under development. Many smart infrastructure facilities rely on conventional architectural solutions that lack adaptability and responsiveness to environment conditions. As a result, this project may achieve short-time efficiency gains, but fail to deliver long-term sustainability and realistics. So, from sustainability perspective, smart infrastructure projects are expected to address multiple challenges simultaneously. Environmentally, they aim to reduce energy consumption and minimizing carbon emission and adapt to climate variability. The life cycle of infrastructure assists socially. They are intended to enhance user comfort, accessibility, and offer quality of life. Achieving this objective required not only smart technology, but also architectural strategies capable of responding dynamically to changing conditions. That's the meaning. It is not just as a fix it, and just need to change it with all infrastructure projects to adapt the dynamic with the infrastructure. So third one, sustainability dimension in smart housing infrastructure. So I'll be quickly with the doctor because I know you need it. Yeah, 2 minutes. Oh, it's long. We are on 4 pages. So I'll pass it this one. I'll give you some. This keys is I think is very clear to you because the big research I did, you know. Dynamic design in architecture is a designed approach based in idea that a building should be able to change, adapt to changing factors of the time, rather than being a static entity. This change includes form, function, or environmental performance in response to the user, climate, or surrounding condition. So this criteria or this element should be clear now, the fundamental pillars of dynamic design. First of all, we have to know that responsiveness, the building reacts to facts such as light, heat, wind, or intensity of use. Second things, fundamental, flexibility. You know, the flexibility have to be change and adapt with the climate surround us. Third one, the movement. So we have to know about the design after executive. So it should be flexible. We can change the space, and we can make flexible to change the wall inside the building, like redesign it. It's easy way. So four things: the time-based design. Fifth one, technology and intelligence. So this factor, fundamental for the dynamic, I think is clear here. How can we conceptual with dynamic in infrastructure? So I'll be now adaptive building envelopes in smart housing infrastructure. This idea, how is it could be the facade using reduce the radiation of the sun, so we can make it flexible facade for that. If there is something resist the radius from the sun, so the heat also will be reduced from inside the building. This is the idea. When you see there is movement, technology can use it for the facade. For the reconfigurable spatial layout of the environment control, dynamic architectural design extend beyond the building envelope, encompass flexible and reconfigurable spatial layouts that support environment responsive finish inside the building. You know, housing infrastructure projects often include a variety of private and semi-private spaces that can be strategically configured to enhance environment performance. So we'll be starting intelligence in the intellectual environment. So I'll be passed it, and here we'll see how the building inside could be adapted with the dynamic, let's say dynamic smart house. So the meaning or the idea of the dynamic, that's mean all smart building or sustainability under the umbrella of dynamic. So the dynamic will be smooth when crash the city or shut down, anything happen for the city, but the dynamic, when you use it, this conceptual or this idea will be smooth for anything from outside happen inside will be smooth, stable, everything. In economy sector or in social sector, everything will be stable inside. So the research methodology, this research adapters descriptive analytical methodology supported by comparative analytical approach to investigated the role of the dynamic architectural design in enhancing the sustainability of smart housing infrastructure project. The methodology is structured to evaluate the effects of architecture adaptability in improving environment performance at the scale of the integrated housing developments, rather than the level of the individual building alone. I will be best because there is the six steps, cumulative analysis of smart housing infrastructure project. Here I did some calculation, not just roughly, but because expand and huge research, just I focus in housing, I put it some, you see here the idea how to dynamic the facade, but I'm going to reduce here quantitative result of the performance analysis. I'm going too fast because 1 minute he told me, but here the key, that's what happens when make research and the result of the focus it in the housing, that's unit I need to use it. When you see here conventional housing, cooling and energy high, and dynamic housing is reduced because improved from 20 to 30. That's roughly when you use it in the housing now. They're using dynamic facade, mechanic shading for that to reduce the heat inside the building. So thermal loading is high, conventional housing, dynamic is moderated. Roughly 25% reduce it. See the figure of the environment performance improvements. You see there is improved from the environment inside the housing because it's coming very, very comfortable with the client inside or the people inside using the housing. Here also we figures with about the result and VS for the compare between the static and dynamic for that cooling energy or natural ventilation, use it for that. How can use it the ventilation about the dynamic housing inside. A discussion, the result of the comparative analysis highlight that critical role of the dynamic architectural design enhancing the sustainability of the smart infrastructure projects. Unlike conventional developments, they rely heavily of mechanical system to achieve environment comfort. Project incorporating dynamic architecture strategy utilizing architectural adaptability as primary means of environmental control. So this is the discussion. We'll see implications for smart infrastructure planning and design. The implications of this research extend beyond individual design solution of informed border planning and design and policy discussion. So, conclusion of recommendation, this research expanded dynamic architectural design as an effective approach to enhancing the sustainability of smart infrastructure projects. Those descriptive, analytical, and comparative methodology, the study demonstrated the architecture and adaptability plays a decision indoor environment and quality. The finding confirmed that dynamic architecture design contributes to reduction in cooling energy demand by approximately 20 to 30% and 25 reduction in thermal loads. So this measurement or measurable for this all stage or all figures in ventilation or the thermal or the environment inside the building, how they influence the dynamic architecture design to the infrastructure, smart infrastructure project. So this is the reference. Thank you very much for listening. I'm sorry I'm trying to preach it because heavy research.
But I also work with planning authorities a lot. I have my consultancy, but I do advisory work with the planning authorities. My last appointment was by the Prime Minister of Australia on the Western Sydney Transportation Infrastructure panel, which was a panel of 8 stakeholders, and we made recommendations about transportation infrastructure, and that led to large-scale funding from the government for transportation infrastructure. We have actually a lot of infrastructure being built in Sydney, which is a very large city. Sydney is a city of about 12,500 square kilometers with 5 million people, so really low density city, but lots of metro lines, other railway lines, light rail, highways, motorways, and so on and so forth. But I thought today I'll present this case of, which is related to infrastructure. So from my experience over the years, that included working with the Sydney Olympic Park. Who knows when were Olympics in Sydney? Do you know the year? Or remember the year when the Olympic Games took place in Sydney? It was in year 2000, so 25 years ago it took place. Now what happens with the Olympic Games is that you spend a lot of money to build infrastructure, sporting infrastructure, parklands, athletes village, and so on and so forth, but for many cities that infrastructure is not very well used afterwards. It becomes a white elephant. It becomes the infrastructure that you have to spend money to maintain, and some countries struggle to spend that money. For example, in Brazil, in Rio, after the Olympics, they have struggled to maintain that infrastructure. Also, in the case of Greece, after Athens Olympics, they also struggled to maintain the infrastructure, Olympics infrastructure, and it's getting dilapidated. They don't have money to do that. In case of Sydney, actually, it didn't happen like that. Actually, there have been, if we look at the history of Olympics, there are 3 cities which did it very well, where this infrastructure is used very well because of certain conditions or circumstances, which I'll explain in a minute. And those 3 cases are the 1972 Olympics in Munich, Germany. So in that case, this is a very successful example where the infrastructure was integrated into the city proper and has been heavily used. The other example, the second example is Sydney in 2000, and the third example is London Olympics in 2012. So these are, I'm familiar with the Sydney Olympic Park example, so I'll just quickly go through the slides. So this is what I explained, that quite often this investment is usually very large investment that you do. So for example, in Gulf right now, there is preparation in Saudi Arabia going on for the soccer World Cup. So this is a very large layout of investment for sporting infrastructure. But what will happen after the World Cup to that infrastructure? So that's the question. So in this case, what happened in Sydney? So yeah, so Sydney Olympics, as I said, was in year 2000. It was, usually you would know about 8 or 10 years before Olympics that you are going to do it, so you have a lead time of 8 to 10 years. In case of Sydney, they knew it in 1991 that they were going to hold Olympics, and then they chose this site, which is now the Sydney Olympic Park. This was a former industrial site. It was where, for over 100 years, toxic industries were. The soil was contaminated. There were landfills for industrial waste, so really toxic. The site was next to a river, and the river was very polluted also. So, but the industries were leaving this site, so this was a brownfield site, and there was an opportunity to improve this site. But the advantage of this site was it was centrally located. So within the metro area, it was very centrally located, easily accessible, and the transportation connections were easy to make. So this is where you see, I don't have a pointer so I can tell you, this is Sydney metropolitan area. This is the CBD area, which is the Sydney CBD, and this is the second largest city, which is Parramatta, and the Olympic Park was here. You can see the river here, and this is the Oh, thank you. Thank you. No, actually, normally pointers don't work on the screen. They work on the whiteboard, maybe, but not on the screen. Thank you, Bud. So this site, which was centrally located, very close to the city, on the river, so the location was really good. So this is a satellite image of the site. So again, you can see the sporting infrastructure, the stadiums, etc. here. And then there is these residential areas which have developed all the way up. And the Wentworth point here is a new suburb which has been built. So this was a very large site. And some of it has become parkland. Now, this is now a very desirable place for people to live. So these are very expensive suburbs, Newington, Wentworth Point. There are residential towers in Olympic Park proper. They are very, very expensive housing. This sporting infrastructure is very heavily used for various sporting events, but also concerts, etc. And also, there are exhibition halls, which are very busy all the time. So it's a very busy place. These parks are very popular throughout the metropolitan, so people come from everywhere to enjoy these parks. This was the problem with the site. As I said, it had contamination, soil contamination, groundwater contamination, river water contamination, heavy metals, asbestos, hydrocarbons, dioxins, and it was a really public health risk, the site was. This was there before, so there were various chemical industries there. In 1928, there was Timbrol chemical factory, which was making timber preservatives. So they are really toxic chemicals. Union Carbide, which is an American company, they were producing DDT and dioxins, really toxic also. ICI, the Imperial Chemical Industries of UK, they were producing various paints and pigments and resins, and so on. There were also petrochemical industries there. So it was really, really toxic site. And all of that had to be cleaned for Olympics. So this was there. So I'll explain in a minute how it was cleaned, but now this is what we see. So on the right-hand side, you can see the new suburbs which are there, new residential areas. These are very desirable areas. And on the left-hand side, you can see what was there before. So from those industries, you have gone to this in the Olympic Park. So there was an environmental remediation program which ran from 1992 to 2000 by the New South Wales government, which is the state for Sydney. So initially, there was an investment of $137 million. And in this remediation, around 9 million cubic meters of contaminated material was managed through recovery, consolidation, and on-site containments. So this is a picture of when they were doing it. So the remediation of past domestic, commercial, and industrial waste site is being remediated here. So these were some of the techniques which were used: waste containment systems, soil management and capping, water-sensitive urban design, ecological restoration of wetlands, and integrated with the land use planning. So this was a huge cleanup exercise. What they tried to do was not to strip the topsoil and then dump it somewhere else, rather to treat it at site, or where they could not treat, they put it together and made little hills. And these hills were contained so that the contaminants don't leak from the hill that was fixed in the hills. So those hills became attractive to look at, or now people even climb them, or there are sometimes spiral paths for bicycle riders to go on top of the hills, and so on. For some parts, they had to cap it with 1 meter topsoil. So they brought more soil and capped what was the toxic material underneath. These are some of the techniques which were used: encapsulation, containment and capping, leachate treatment, and risk management. So after the Olympics, the site has transformed. It was a very successful Olympics. There was additional transportation infrastructure which connected Olympic site directly with the Sydney airport. Some of it was already a train line, but they made the rest of the connections. And the people who came for Olympics, they could take a train directly from the airport to the Olympic site. So this was enabled by a very good governance and planning framework. So there is precinct level governance. So there is something called Sydney Park Olympic Authority, Olympic Park Authority, Sydney Olympic Park Authority. There was long-term regulatory controls. There were environmental performance standards set, and a staged approach was adopted. Also, ongoing infrastructure investment. Actually, right now, there is another metro line being built which connects city center to another city, which is Parramatta. And this location falls in between, so there is a train station for fast metro on this. So the investment continues. This is the train station which was built for the Olympic Games, but then this is the new train line, metro line, which is being built. It's under construction to be completed in a couple of years. This is all underground, about, I think, 25 kilometers long. And Sydney Olympic Park, you can see, is one of the stations because there is more population and they need to take public transport. So this is what we have over there now. So we have outdoor spaces and parks, very popular parks. We have activities and recreation. There are many, many events taking place over there. There is dining, there is retail, and lots of residential and commercial activity. This is some of the new buildings in Sydney Olympic Park. These are the high-rise apartment buildings in Sydney Olympic Park. But there is low-rise also. So this is not low-rise really. This is like middle-rise day and night view of Wentworth Point neighborhood, which is built within Olympic Park. You can see it here next to the river. This was an athletes' village. So this is where athletes stayed. This was built after an architectural competition, international architectural competition, which was won by Philip Thalys, which is a renowned architect. He designed it. It's designed actually quite interestingly. If you go through the suburb at the ground level, it's quite pleasant. So, and this is a very expensive suburb now. So a house in this area would be about $1.5 million if you try to buy it today. So there are several parks in this area. This is an example of one of the parks, which is Bicentennial Park. It's a very attractive park, and many, many families come here over the weekend. Actually, is very, very busy, and parking in this area can be difficult. There are many concerts going on in the stadiums, in addition to the sporting activities. This is the example of Coldplay, which is a musical group playing their concert in Accor Stadium. This is the largest stadium there is. So utilization and legacy outcomes. So it's a strong post-event use of major venues, high recreational use of parklands, very high residential demand, and there is a lot of employment also available in the area. This is a highly desirable urban location. Many young families move here, educated families. We call them DINKs. DINKs are the double income, no kids. So DINKs, families, so they are highly educated, and they like to live at a place from where travel is easy, and they live in this area. So this is the outlay since the Olympics. There more than $2.5 billion have been invested in here. for various pieces of infrastructure. This doesn't include the metro line, because metro line itself is much more expensive than this. This was the money that was spent on the precinct. Now we have two more plans for it. One is the master plan for 2030, another one is master plan for 2050. And I'll skip this. This is the apartment prices in 21. So in future, further residential development of this type is planned for the Sydney Olympic Park. So if I conclude, this is a case where the Olympic infrastructure was built strategically at a location which was very desirable. It required cleaning and initial investment, but long-term commitment to the site has led to, and long-term planning of the site has led it to be very successful. I have a few more slides, but I'll stop. I was stopping everyone else, so I should stop too. Thank you so much. I'll be happy to answer any questions that you might have. Mm. Yeah. Mm. Yes. Yeah. Yes. Mm. Yes. 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 So there are several stages in it. Okay. Yeah, so the 2050 plan is new. So at that time, they planned up to 2030, not up to 2050. But now more stages are being added, which were not initially conceived or considered. So those stages are being... Yes, but still, they had this idea when they chose this site that after Olympics, this will become a residential commercial area. That they knew always. And they knew this would be successful because of its location. In London, they did the same. It was very close to the city. It was the Docklands in London, and they cleaned it up in London also. In Germany, in 1972, for them, it was an airfield, which was close to the city, but it was abandoned, so nobody was using it. And they took the opportunity, and with time, it became part of the city proper. So this way, yes. Yes, so in case of Munich, Sydney, and London, this has been done well. Yes. So they had 8-9 years to clean it up and build the infrastructure. So they started in 1991. The Olympics, their deadline was year 2000 when the Olympics were. So they had to do everything in that period. Huh? Before, of course, before, because, that was the time frame they had. How much they spent? They spent, I think I had the figure, about $140 million for cleanup only at that time. So in today's money, it would be much, much more than that. But at that time, that was for the cleanup. That doesn't include the land cost. So because one of the big problems in Sydney is land consolidation, because land mostly is private. So it belongs to, so in this case, it belonged to various industries. So you had to buy it from them and then consolidate the land. That is quite often a very big issue for us everywhere, because people have very strong property rights. So you cannot, in this case, they could do it because they declared it essential infrastructure. if you have a case of essential infrastructure, then the government have the ability to acquire land, and they pay the owners. But if you try to do only residential development, you cannot acquire land from, and it's not easy to do consolidation. If no other questions, then thank you so much. Really appreciate it.